Alright, so we are going to talk about Unit 3. This is the first part. This is what we did Monday, September 20th, September 20th actually. It was on the atom and periodicity. You can find these notes on Blackboard along with the link. Alright, so the first one we're going to talk about is atomic theory. That's the idea that matter is made up of atoms, which are the smallest pieces of matter. The way I'm going to do is, because YouTube limits me to 10 minutes, I'm just going to kind of go through the notes really fast because they're not all that important. You can get the notes and you can copy them down a little bit later if you want to. I just want to show you what is going to be on the exam. So right here you have your bulk matter, which if you looked really close to it, it would be small pieces of individual atoms. And then right here it would break it down. You have protons, neutrons, electrons. Now the ancient Greeks believed in 4 basic elements. Okay. What they believed in was fire, earth, water, and air. It was mainly proposed until about this time by Democritus, 460 to 370 BCE. Now, he lived a really long time, which is not common then, but that's another story for another show. He proposed the world as empty space and atoms. Atoms, to them, it's Greek for meaning the smallest indivisible unit. It's correct in the form that with an atom, you can't have, if you go to like atoms of magnesium, once you break it down, there's protons, neutrons, electrons inside of that magnesium atom. Well, all the atoms are made of protons, neutrons, electrons. So technically it is correct. Atom is the smallest indivisible piece of matter that is the same, or is different from everything else. So this explained why they were able to see the changes that happened. Now we jump from the 460s BCE all the way up to the 1800s. Dalton's atomic theory of matter. It states that all matter is made of atoms. Atoms are indestructible and indivisible, and atoms of one element are alike but different from atoms of another element. So right here, this part, atoms are indestructible and indivisible, that's not correct. We can make atoms go in, and we can change them, we can blow them up, we can break them apart, we can fuse them with other things. We can make them lose electrons, we can make them lose protons. That's no big deal. So, on your test, what's going to happen is if you see this part right here, Dalton, which part of his theory is wrong, that's what the test question is going to be about. Now, we go over here to Thomson. Thomson had this experiment, he called it the cathode ray tube. What it is it's basically like your TV, not your brand new plasma or LCD, talking like the old ones that used to be in like computer monitors before everybody got a laptop. In these screens, or the cathode rays, what happens is it emits a beam of electrons at one end, and then it beams it towards the other end. If you move a magnet towards it, what will happen is the electrons from there will go up towards that magnetic plate that's at the top right here. And so they were released, and so what happened was he found out that there was these things called electrons inside of an atom. So he said that they were charged particles inside of there, and that some were negative and some were positive, because overall they're neutral. We know that for sure, and they knew that back then. Protons were discovered much the same way. With Rutherford right here, he discovered the nucleus of the atom using a gold foil experiment. So with this last part, with Thomson, it was the cathode ray tube, that was his experiment, and he discovered the electron. With Rutherford, it was the gold foil experiment, and he discovered the nucleus. Now, what they were thinking is that this is what the model they thought was there, that there was a diffuse positive charge and that there was electrons scattered throughout, because we knew that there was electrons. We didn't really know if there was, protons in there somewhere. But what ended up happening, what should have happened was that they all should have ended up on this side of the gold foil, maybe a little bit of diffraction. What should have happened is this part right here. What actually happened was this right here. Some particles are scattered all the way throughout. Now, because that happened, he proved that there was a nucleus inside of the atom. And so with that, what he did was he discovered that there was a nucleus inside. And he said that it was mostly empty space inside of an atom, and that there was a charged nucleus right in the middle. And again, that's a really, accurate drawing. Not really. That's what Rutherford's gold foil experiment discovered the nucleus. Okay. Now, Nagaoka, he discovered that there's positively charged nucleus, good, but that electrons orbit around the nucleus like Saturn's rings. Okay, that's not so important. Chadwick discovered the neutron. What they found out through testing was that their elements the nucleuses were heavier than what they should have been. And so what they proposed was that there was a neutron inside to make up this difference, because they couldn't really explain it any other way. Niels Bohr, weird looking guy, but kind of cool. What he proposed was that electrons are in this thing called an electron cloud that are a given distance away from the nucleus. The smaller the orbit, that means the lower the energy. The bigger the orbit, the higher the energy. Think about like a racetrack. If you're on the outside of a racetrack, you have to run farther, and if you're trying to stay up with somebody, you have to go faster in order to be at the same pace. Now, the structure of the atom. There's a nucleus. It's dense, central part of the atom. Its protons, neutrons are found in the nucleus. The electron cloud is a large area outside of the nucleus, and that's where the electrons are at. So here's right here. Now, one thing to remember with electrons, they are extremely tiny compared to the size of a proton. We're talking about thousands of a difference. So kind of like you jump on the back of a semi, you're not really going to affect that much weight, okay? And so that's what the difference of the electron is. Most of the mass that we get is from the nucleus, the proton and the neutron. Okay, that's it for now.